All right, so today we are going to start talking about how to calculate average speed for a trip, and then how a table and graph of time and distance data show speed. So speed in terms of miles per hour or kilometers per second or whatever. It just is a matter of distance covered in a matter of time. It all boils down to the ratio of distance to a specific unit of time. So let's take a look here real quick. We'll scroll down. Let's take a look here. It says that Malcolm noticed that on day one, cyclists sometimes went very fast or very slow in any given hour. He also noticed that the cyclists covered 45 miles in 5 hours. So that he claims on average, the cyclists covered 9 miles per hour. Is he correct? Well, if we look at the trip overall, from start to finish, from the time they left to the time they stopped, as a total, in that 5 hours, they covered 45 miles in 5 hours. Okay? So if we look at that in terms of the overall trip, then they did, in fact, when we divide out 45, we divide 45 miles by the number of hours, okay, which was 5 hours, okay. 45 divided by 5 is 9, and that gives us 9 miles for every hour, or 9 miles per hour. But then the next little question there says, did the cyclist actually ever cover 9 miles per hour on day one? Explain. So looking very closely here, if we start looking at the hour by hour or even the half hour to half hour distances here. So let's start looking up here at our table. Let's start looking at whole hour increments of time. So 0 to 1. From 0 to 1, from the 0 hour to 1, they went from 0 to 15. So in this hour, from 0 to 1, they went from 0 to 15. So in this increment of time, they averaged 15 miles per hour. Okay, from 1 to 2, they averaged 10 miles per hour. So they actually are going faster than that average of 9 miles per hour. Okay, from hour 2 to hour 3 in that 1 hour span, see each one of these is 1 hour. See 1, 1, 1. From hour 1 to from hour 2 to hour 3, 25 to 34, they covered 9 miles per hour. Okay, but from hour 3 to hour 4, they must have been getting tired, or they stopped for lunch, or one of those many things. They only went to 4 miles per hour. And then from hour 4 to hour 5, that 1 hour time frame, they only covered 7 miles per hour. So again, those last 2 hours of the day, they actually got slower. So they started off that first hour really going at it hard, 15 miles per hour, and then slowly decreased their average speed throughout the day. But throughout the entire course of the day, over the course of 5 hours, actually averaged an average speed of 9. So average takes into account all of their speeds. If we go from half hour to half hour, if we look at 0.5, so like from half hour to half hour, this hour, from 8 to 9, okay, or 8 to 19, he averaged 7 miles per hour, okay, for this 1 hour. So that was 7 miles per hour. 1.5 to 2.5, they traveled 19 to 27. So that was an increase of 8 miles per hour. Okay, 27 to 31, they did an increase of 4 for that same hour. So if we just kind of look at it hour by hour, we can break it down and apart. From hour 3.5 to hour 4.5, if we look at that half hour, or that hour time increment, they went 31 to 40, that would be a 9 miles per hour coverage there. So there are two different instances in this table where they actually did travel 9 miles per hour. So again, the average speed for the entire day was 9 miles an hour, but there's several instances where they traveled faster and a couple where they traveled slower, and that's why they did average, which is the total distance divided by the total time, and that gives us their average speed instead of a speed 1 hour and then the next speed another hour and then another speed. So we're going to continue doing problems like this. Some of them will actually take a look at graph problems. So we're going to take a look at one of those real quick, just so you can kind of get an idea for one. So hold on just a minute. Okay, on this mimic of a tablet here, I've got a graph displayed. This graph, I've got a point highlighted in purple. The point is at a time of 7 hours and a distance of 50 miles. And over here at the side, I've got an ordered pair of 750. And I'm simply going to ask, what does the point 7, 50 tell us? And what this tells me is that after 7 hours, they have traveled 50 miles. And so we can tell a couple of things. One, we can tell that after 7 hours, they've traveled 50 miles. We can also determine that based on this, if we look simply at the distance from hours 6 to 7 on the graph here, if we connect the distance here, see how shallow that line is from 6 to 7, 7 to 8. It's kind of a shallow line. They might be traveling on a stretch of road, or they might be getting tired, or they're fighting a wind, or they're traveling uphill, or it could be that just like they did on that first day where they stopped to play in the ocean. There could be a myriad of things going on here to indicate what is going on here in their progress. We can also use this information to figure up their average speed so far. We can take that their mileage, which was 50, and divide it by their time, which was 7, and we're going to get that we have, and again, we're going to divide this out. So we divide 7 can go into 57 times. We get 1 left over. Add our decimal, bring it up. 0, we get a 3. Bring that down. 7 can go into 30. 4 times, that's 28. Get a 2 left over. And this is going to be a repeating decimal when we divide by 7. So we're averaging right now, our average speed is about 7.15 miles per hour. Okay? So there's lots of things that can tell us. It also can tell us that they are starting to slow down. It's later in the day. They've ridden for 7 hours. They've covered 50 miles, so they've ridden a long ways. So just be ready for a couple of questions like this as well. Be ready to find your average speed. Know that if you are given a graph and asked to find average speed, for instance, if I asked you to find average speed for the point here, for 11, 145, which would be this one right here, you should be able to do that now. So thank you.